A rational function r of x equals p of x over q of x, having been written in the lowest terms, will have a vertical asymptote x equals r if r is a real zero of q of x. That is, if you set q of x equal to 0 and solve, the solutions will be your vertical asymptote. So we got to take our rational equation, make sure it's in simplified form, and then set the denominator only equal to 0. So we have our first function, f of x equals x plus 3 over x minus 1, and we're going to find the vertical asymptote. I can see that it is in simplest form already. There's no way to simplify it down, so I'm just going to take the denominator, x minus 1, and I'm going to set it equal to 0. And now I'm going to solve. I'm going to add 1 to both sides. I'm going to get x equals 1, and this is my vertical asymptote here, x equals 1. And that's it. Next, g of x equals x over x squared minus 16. Again, it is in simplified form. No way I can reduce it down. So I'm just going to take the denominator, x squared minus 16, and set it equal to 0. Now I'm going to solve. I'm going to add the 16 over, so x squared equals 16. And then I'm going to take the square root of both sides, and I'm going to get x equals plus or minus 4. So here I actually have two equations for vertical asymptotes. I'm going to have x equals 4, and I'm going to have x equals negative 4. And both of these will be my vertical asymptote. For h of x, we have 7x squared minus 4x over x squared plus 25. And though as weird as it looks, there's nothing we could cancel from top and bottom, so this is as simplified as we can make it. So I'm just going to take the denominator, x squared plus 25, set it equal to 0. Now subtract 25 over to the other side. X squared equals negative 25. Take the square root of both sides. X is going to equal plus or minus 5i because of the negative there when you take a square root. Because I have a complex number here, 5i, this has no vertical asymptote. So if you have a complex number in there, there is no vertical asymptote. We want only real numbers. Last, f of x equals x squared minus 9 over x squared plus 4x minus 21. And here, I can do some simplification. The top is a difference of squares, so I can say this is x plus 3 and x minus 3. And in the denominator, I can say that this is, or I can say that this factors down to x plus 7 and x minus 3. And here, the x minus 3's will cancel out, leaving x plus 3 up top and x plus 7 in the bottom. Now that it is simplified, I can find my vertical asymptote, which is just taking the denominator, x plus 7, and setting it equal to 0. So when I subtract the 7 over, I'm going to get x equals negative 7. And this will be my equation for the vertical asymptote for this rational function.